Good morning, everyone. Hope you enjoyed the keynote talks. This is going to be much more of a workshop, so if you can get out your laptops, we're going to be doing some coding. If you're not interested in coding JavaScript, then probably want to watch one of the other talks. But I'm going to be going over some basic stuff first, so even if you don't know how to code, I'm going to cover some basics really quickly, and then we can move on to some more advanced stuff. So that's the format of the talk. Get your power plugs plugged in. And who am I? I'm Mark Nadal. I'm a bit of an enthusiast. That's the tiny little guy up there is me. I like to climb on top of things and find scary ledges. And I founded GunDB. The story of kind of where I came from is I'm much more of a tool developer or a systems person. So my background is much more in mathematics and logic and philosophy, but I didn't really like academia, so I dropped out and kind of found out, a career as being a rogue mathematician probably wouldn't go anywhere. And I then jumped into programming, thinking that programming had to be similar to logic, right? No. So spent a bunch of years figuring out those ropes, and then I kind of settled down upon JavaScript as being my favorite language because it's so quirky and weird and strange and front end. And I like approaching things with front end. So my previous startup was a collaborative web design tool. And as I was building that, I kept on having problems with my database. It would crash, the file system would go corrupt, and then I eventually realized the whole NoSQL versus SQL debate was a whole debacle, and I kind of wanted to have both. So I prototyped out Gun about a year and a half ago, posted it to Hacker News. It jumped to the home page. It was on the home page of Hacker News a couple times. And then in that meantime, I got invited out to an incubator in San Francisco, a Bitcoin incubator, where I worked on it full-time from there. And then in January this year, January of this year, I launched Gun. We hit the top 4% of NPM, and I raised some money. So now I'm here getting to talk about it. I just flew back from Berlin from another talk at Distributed Matters and UtahJS. So that's a bit of a story, and then I'm going to be going into just what Gun is, and then we're going to jump into some demos and coding. And as a shameless plug, since we just raised some new money, we're hiring. So if you guys are interested in database stuff, JavaScript stuff, distributed systems, please talk to me. All right, so the first thing that differentiates Gun from a lot of the other mainstream databases is that it's a graph database. And the nice thing with graphs, as I mentioned, is that you don't have to worry about whether something is a relational or a table approach or something is a document or a tree approach. Graphs allow you to do both. And this is because in mathematics, there's this nice property where a table in mathematics is a matrix, and in mathematics, a tree or a document is a tree. And both trees and matrices can be represented as a graph. So you no longer have to worry about this battle between NoSQL or SQL. If you use a graph database, whether it's mine or somebody else, you should be able to get the multi-model approach. So you can have key value, you can have documents, you can have relations, and you can do graphs. So graphs are pretty awesome in that way. The other thing, which the keynotes have been talking quite a lot about, is we're kind of moving into this push-based architecture of the web. We want things to update in real time, and so that comes baked in with Gun as the database. So you don't have to do, as Mike in the previous talk was talking about, you don't have to worry about constantly pulling the database. Question? Or you don't have to worry about constantly pulling the database. It just pushes the changes out to you and makes your life tremendously easier. And then Firebase just added this offline first. They announced that at Google I/O. And same thing with Gun, it's offline first. So if you're going through the subway or you're out in the national forests and you write some message and hit send, it obviously can't send it, but then when you come back into an area that has network, it will deliver it for you. So yay, there's lots of things you don't have to worry about. But personally for me, I think the coolest part of what differentiates Gun is that it is fully peer-to-peer, otherwise known as a master-master architecture or a masterless architecture, whatever buzzword you want to go with. So, because Gun is written in JavaScript and it is entirely peer-to-peer, we haven't implemented this yet, but once we get WebRTC enabled, you could essentially run your entire app from browser to browser without any in-between server. So that's kind of the direction I'm trying to go with Gun, where you can just focus on building the front-end app, and then not only do you not even need a no back-end service, you theoretically could not even have servers. Now, realistically speaking, you probably will want to have a server for the service you're providing just for reliability.
Well, obviously, somebody's got to download the code from somewhere.
Yes, yes. But once it's been downloaded, it's cached, and there's between WebRTC as well as I forget the name of it. I forget the name. Your code and your content can be cached on the client as well. Service Workers is one of the newer ones. It's the one before that people were making fun of. I'm just blanking on the name of it.
So after client A starts with the app, client B connects to client A and gets the code from them?
Theoretically, not currently, but yes.
That's where you're going.
Yes. All right, so let's jump into a demo of those 4 pieces. So I have a local copy of Gun installed, and we'll go over that. I'm just going to spin up a server because, like I said, right now, you do need a server for delivering your content, but the tutorial we go through won't require a server. So I'm going to start npm start and spin up my trusty old Chrome, which, of course, is a memory hog. Go to localhost 8080, which is where I'm running the server on, and open a new tab. And, whoops. This is the example app. You get the real-time updates baked right in. So that right there is 3 lines of Gun code. So it's really, really simple to get that real-time behavior. This entire app right here, the admin JSON editor, is less than 100 lines of HTML, CSS, and JavaScript. And we're actually going to be going over a tutorial that builds something similar. But here's the sweet part, okay? If I crash the server, I have a local copy of the data on the server. I'm going to delete that from the server, okay? So the data is wiped from the server. Oh no, we're screwed, right? Because this is the worst possible nightmare you could have. Your server is down, users are using your app, and the database is corrupt. So I'm going to make conflicting updates on these 2 peers while they're offline, of A over here and B over here. And as proof that they're offline, I'm going to refresh both, and you see that they are not able to work because they're still getting, yes, the content from the server, the static apps. I'm going to change the port. Nothing magical is happening here. Chrome just likes to aggressively reload the page, and I want to intentionally show things as being disconnected. So I'm going to spin up a new server. This server does not have the previous data on it because that got wiped. And once it comes back online, you're going to find out that because Gun is in JavaScript, the database is running on the client peer, okay? So we recovered that data, and that data now synchronizes back up to your server. So you've been able to fully recover from that. But even cooler is when we bring the other guy with the conflicting update online, they're both going to converge to the same update, okay? So that's a demo of the real-time, the offline first, and the peer-to-peer architecture. I literally lost every single peer in the system in terms of servers, but the sweet thing is because it's also running in the browser, I'm able to fully recover. So I hope that is pretty impressive. The Firebase was showing off the offline support, and in this case, it goes beyond just the offline support. You can essentially lose all of your servers and still manage to recover. Now at this point,
So this guy's data didn't get clobbered, though.
So yeah, about that actually. So the way that the data is structured, it's an immutable append-only structure. So this real-time update that's happening to each other is the log that's happening. And so when one guy wins, it's not that the other person's data is lost. Right now it's lost because I don't have the log enabled, and I'm still building that feature out. But what happens is that update gets the peer's update that got clobbered gets pushed below the update that it came in. And as a result, once we get this feature up and running, we don't have it yet, you'd be able to scan back in time to that previous update. And theoretically, if you wanted the user to be in control of which update should win, you could scan back in time, find those conflicting updates, present them to the user, and then they could resave it. So the data isn't actually lost. It's just pushed below, kind of like a time series database. And you only see the most recent. However, how most recent works in a peer-to-peer system gets pretty complicated pretty quickly, and that was the talk I did out in Berlin just a few days ago, and so I'm not going to be going over that in this talk. But if there is spare time after I do the tutorial and get you guys up and running with some code, then yes. All right, so if you go to gundb.io, you'll hit the splash page. It also redirects to gun.js.org, and you click on fork me in GitHub. There's the code. It's released under MIT, zlib, and Apache 2, so it's very, very open and liberal. You can do whatever you want with it. But we're going to jump through the tutorial. So anybody who has a computer or doesn't have their computer open it up now. On the home page, there's a quick little kind of explanation of how to get started, which is, let me boost up the text there. Can anybody read that? Like Firebase, we say, hey, var gun equals instantiate new gun instance, and we point to a peer that we want to talk to. In this case, it's just a Heroku server. And then we're going to say, hey, gun.put hello world. So we're putting in some data, and we're going to assign a key to that so we can recover it later. I'm going to click run, and then the next thing we're going to do is say, hey, that reference, let's get a reference to that key that we just made by doing var ref equals gun.get, and then the key that we just saved to. And then all you have to do to get the real-time updates is ref.on, and then we're going to basically stringify the data out as the updates happen. And so we're going to click next. It's going to pull up an example of 2 tabs, and I can then make some changes. And when I hit send, it updates. And this is not faking it. This is actually running through the current server. If I change it again, yay, it updates. I can then change the field that we're updating, so to boo and lol, and that adds a new property to it. All right, so has everybody hit the home page and run through that? Because now we're going to jump into the tutorial on how to get started, and the way you access that is by clicking next, next, next on those 3 tutorials. Is everybody there? Is anybody there? All right, well, you don't have to follow along. You can watch me blabber. So if you click the click here to get to the next tutorial, let's let the internet slowly load in the editor. And this is for anybody who's unfamiliar with HTML. I assume most people here are familiar with HTML and JavaScript? Yes? OK. So I'll skip through that part. It's just an introduction to what HTML does, to change the H1, you can update. And then we're going to do our trusty thing where we say, hey, let's grab, actually, rather than typing the code, I'll just hit next. So we're going to add the script tags in order to use gun, and one of the script tags is rawgit.com/a/mark/gun/master/gun. You can also use another URL of gun.js.org/gun.js. That's a lot simpler, and it's ultimately the same file. And then because I don't really like doing DOM manipulation by hand, I'm just pulling in jQuery to keep things simple. And then we got that alert message a few moments ago proving that it did work. So now the next thing is to build this to-do app. We need a form submit handler to grab the data. So we're going to add that into the code, which it adds in. And as proof, if I type in get groceries, I get the alert message. But now we don't want to just have an alert message. We actually want to save the data. And to do that, we have to initialize gun. So like I said before, we var gun equals gun. We instantiate it. In this particular context, we're not connecting it to any other peer. So it's just a local database. And then we're going to get false. And that's just the key that we're going to be saving all of our data to. So let's add that in at the top. And then rather than alerting the message, we're going to replace the alert line with gun.set, the value of the input, and then clear out the input so we can add new stuff. So yay, I can add get milk. Now, we don't see that yet. but that's what this next step is for. So with gun, you do something as before, as you saw in the previous tutorial, which is you just do gun.on, which is to get a live update of the data. But then we want to map over each item in the set. And that's why it was called gun.set. You're adding an item into a set. And we want to map over that set. And that's just a little bit of jQuery to get it to render out to the page. And you see we have those values. Yay, it works. So that is literally how simple it is to get up and running with gun. That this tutorial is even accessible by someone who hasn't even seen HTML or CS or JavaScript. And then the last step, if you want, is if you want to clear out items, I just do this janky double click to null out the value. All right, so that is the tutorial. And then there's another tutorial, which is incomplete, that goes over how to then connect to another peer and get the real-time updates, and it's built off of the previous one. So at this point, we're going to now break into more of a workshop, or if people want to have fun spamming the server, you can go to gunjs.herokuapp.com, and it has the exact same example apps that you get when you npm install gun running, and so you can have fun spamming people with messages. So at this point, I'm going to open up to the audience. Which approach do you guys want to go down? Do you guys want to go down a front-end only approach where I don't even touch Node.js? Or do you guys want to see how to get started with Node.js? Node.js? All right. So in which case, again, go to gundb.io, hit the GitHub link, which is right there up in the corner. And all you have to do, and this depends upon what system you're on, but if you already have Node.js installed, all you have to do is npm install gun. And then down here to get the demos up and running, you npm install gun, cdn node module/gun, which is where npm puts it, and then you can just run node example/http.js8080 or just do npm start, and you'll get the exact same thing that you saw earlier. So how many people have followed along at that point? Or, yep, you have? Is it up and running? Does it work? OK. And then you just do cdn node module/gun to get into the repo, and then npm start, or let me bring that up some more. Boom. So it's that simple if you already have Node installed. There's a couple of disclaimers, which is you might need to use sudo if it doesn't work. You might need to make dir node modules if that doesn't already exist. But it's fairly simple to get up and running. So that is how to get started with Node. And like I said, that was the demo. You can run that demo I showed you yourself, where you try and do some updates, and you crash the server, you delete the data. As a warning, the data that gets saved on the peer that I deleted, that's only for local testing, so don't ever use that in deployment or production, because the module that dumps the data to a file on disk is pretty horrible. I highly recommend using one of the different modules. I personally like to use the Amazon S3 module, which backs all the data up to S3 when I'm in production. Well, I can't say production because Gun's not production ready or stable yet. All right, so at this point, do you guys want to run through how to do key value, relational stuff, or do you want to ask technical questions? Well, I'm going to open it up to you guys. This is supposed to be more of a workshop approach. Don't be shy, yes? OK, yes, so local storage has only 5 megabytes of limit, and that means the client obviously can't store much. There are really sneaky, hacky ways to get around that. There's a friend of mine, Faraz DJ, local storage disk fill, where the rules on local storage, I think it's something like that. It's this top one right here, where the rules on local storage is per domain, where a domain is specified as a subdomain. So you could theoretically have your server generate an unlimited number of subdomains, and his demo will actually download like gigabytes and gigabytes of cat photos into the browser, to the point where your computer starts to show a warning that it's out of space. So there's hacky ways to get around that, but I'm not doing that because that's a little scary, and it requires some more server-side components. And that's why you get 3 different options when you use Gun. Because Gun has a very BitTorrent or Bitcoin-like approach, if you want to run literally from browser to browser in a fully peer-to-peer manner, yeah, each browser tab is only going to have about 5 megabytes of storage, and you're going to have to distribute that across all of the peers. But because it's designed that way, it also is it's a one-way street that goes upwards. You can also design it to work in a federated system, like email. So you can run gun on a server, and that server then has a backup of all the data that the user or client can't store, and that gets pulled and synced down. And then finally, if you are actually running a company or a service, you probably want to run that in a centralized manner. And so you can do that as well. You can run gun in a centralized setting, but get all the robustness guarantees of a decentralized distributed system. Does that answer your question? Yeah. So yes, there's limitations of the browser, and they're small, but it then just depends upon what type of app you're building, how you want to work around that. Any other questions, or I'm just going to jump into showing demos of how to use the different data structures. Yes, 2 questions. Matt.
You might have talked about this in Berlin, but just really quick summary. Suppose you have 100 users of a gun app, and they're all offline, they all make conflicting edits, they all come back up online. Who decides what is correct? Do all 100 have to say, or?
So, the way, and my internet's probably too slow to actually load my talk from there. The way it works is that there's 2 bad ways to go about it, which is timestamps have a vulnerability that if you set your local machine to 2 years in the future, and you use timestamps to resolve that update, then the person who has set their clock to be 2 years in the future is going to win for the next 2 years, overriding every other update. And that kind of sucks because somebody can easily exploit the system. The other approach is vector clocks. However, vector clocks, for the most part, either require a permanent number of machines known in advance, and so it's not fluid to be able to, if you're running in like an elastic ephemeral environment like Amazon, you can't just spin up a whole bunch more peers and then shut them down, because each client has to have its own vector clock, and when they spin up and down, there can be collisions that happen. So they also have some vulnerabilities. There's a couple different versions of vector clocks. And then what I do is I combine both of them together, and I say, hey, it's relative to the machine that's operating, and it's defined by this boundary function. It's getting into some like middle school math, so don't freak out. So boundary function is an open closed interval from 3 to 5, where you include 5 but not 3, and that represents the state of the machine. Okay, so if and then below it is the historical state, essentially the immutable log. We haven't built that. The architecture is designed for that. I just haven't added that feature. So the historical state would have all the old data that is not in the current live view of the data, and above it is the deferred state, and then the question is what happens at these boundaries and around the boundaries to deal with conflicts when you have tons and tons of different peers colliding. And the way it works, we're going to use integers right now to explain it, is that if we get an update from the quote future, that gets deferred. The processing on that gets deferred. So this gets around the timestamp exploit. So the malicious peer will literally have to wait 2 years to get an ACK on that message. That message won't get processed because it's at a state that this current machine is not in. I'm just jumping through this really quickly. And that gets around all sorts of problems. Like Google with Spanner has atomic clocks that they spend tens of thousands of dollars on to line up the precision on those things. And this is a nifty workaround when you assume that the peers don't have synchronized clocks. If you get an update with the state 3, which is below state 4 of hello sun, that gets recorded, but it doesn't get transformed into the live view. And just a note here, the lower boundary is defined per individual universally unique record of your data. So the lower boundary is different per data point, and the upper boundary is relative to the machine. So let's say we get hello Venus, state 5. That is within inside of the boundary function. So it gets processed successfully, and as a result, it becomes the new lower boundary for that value. And the upper boundary arbitrarily expands to, let's say, state 9. And when that happens, it has now arrived at that state which we had gotten the update before. So now we need to process it. So we process it, hello Earth, and that successfully works, and now it collapses together. And then over some amount of time, the upper boundary expands again. Let's say now we have a direct conflict on the lower boundary because it's open of hello Mars, state 9, compared to hello Earth at state 9. In this case, there is a potential case that if the states are exactly the same, that they might actually be the exact same value, in which case it doesn't matter which one you choose because all pairs will resolve. But in the case that they're not, they're conflicting values, I do something really, really, really naive, which is I just look at the lexical values. I do a lexical sort on the values. This is how I'm specifically implementing it. Other people can change that, but it's just so ridiculously simple and it guarantees convergence because every machine in the universe is guaranteed to have alphanumeric sort. So it's a deterministic algorithm that allows each peer to say, oh, I know which value to converge to, and that's what happened in that update I showed, in the demo I showed you, without having to do any extra coordination between peers. And as a result, I show here that the Hello Earth update gets bumped below the lower boundary, and the Hello Mars at state 9 becomes the new lower boundary. And as a result, you get convergence. My previous slides was showing the examples of how, oh, that's vector clocks, how the universe isn't very strongly consistent, and if you were to do an update, and it takes 4 to 20 minutes for these updates to pass between. The interplanetary example here is an example of just getting on the subway and you get disconnected for about 4 to 20 minutes. These two things are going to diverge, and if you use, and the ways you can get around that is timestamps and vector clocks, but they have their own problems. And so this is how I approach it. Later, we're going to be then building, so by itself, it doesn't do much, but it does give the convergence across as many peers that are on the system. And then if you want to do higher level business logic, like banking or finances, you find a particular like conflict-free replicated data type, CRDTs, that specifically address your particular business needs. So the goal is start with something really, really simple, right? And then depending upon what the complex business need you have, you specifically add that. The first part of the talk was going over how most databases out there are master-slave, and that leads to all sorts of absurd levels of complexity because you're trying to coordinate it, and there's all these failure cases that might happen. And it then eventually leads to Raft and Paxos, which is difficult, and it's then also a lot of hand-waving. So there is one case in which I say strongly consistent systems are necessary, which is to get around the double spending problem, but I've already rambled way too much on that side. So I'm going to shut my mouth there, and let's jump back to any other questions. Or has anybody been able to get the server up and running and played with the demo? OK, you have?
But your architecture seems really, really friendly to a functional reactive style.
Yes.
Like integrating with Elm at all or anything like that?
Elm looks really cool. I haven't gone to look at it. But yes, essentially what I'm doing is describing a relationship between functional approach and procedural approach, and then Gun is the map between those two things. In fact, I had another talk which kind of explained some of the physics and the philosophy behind that, how that works. So yes, it is very functional and reactive. And in my tutorials, the few that we have, we don't have a ton of documentation yet, I push people in that direction because it makes maintaining state much, much, much simpler. And your code becomes a lot smaller. Like you said, that to-do app was like, that we built in the tutorial was only like 10 lines of code. And in all the other apps I've built, I keep on getting surprised that like they're just more complicated versions of a to-do app. Not in all cases, but a lot of cases. All right, any other questions? We have about 7 minutes left. Yes?
In ArangoDB, they have a notion of vertices and edges. You mentioned yours is a graph database.
Yes. Arango is awesome. They were actually the guys who were helping put on the Distributed Matters conference out in Berlin, and they were the ones that got me in. So let me jump. So right now, Gun is, by default, it's just a directed graph. So it doesn't provide backwards connections for you. If you want to have an edge node, you put a node between two other nodes that has a certain type to it. So a lot of the other graph databases have the edges baked into the system, like Neo4j, and you can't get around that. They have to be there. And those are very, very, very useful for certain problem sets, especially with graph-related stuff. But not all the time do you want to have the forward-backwards linking. And in Gun, that doesn't happen by default, but I'm gonna be adding a module, or if you want to help build one, that will automatically do that for you. But Gun at its base does not do that. So the type of graph that I'm talking about is more a in-memory JavaScript object, where here's an example here that, and I'll probably actually put this into code if I have the time. Let's say we create a JavaScript object of Mark, and then we have a JavaScript object of Amber. And then we assign the husband field to my JavaScript object of Mark. What winds up happening, if we were to do a JSON.stringify on that, has anybody done that before? What happens? It pukes because it's a circular reference. And that's a graph structure, having the circular reference. And so with Gun, you can actually just toss that value into Gun, and it's going to normalize that to first order form in the background for you. And then when you pull the data out, it'll recombine it into that object. So by graph, it's very low level at this point. I'm taking the Node.js philosophy with Gun. Gun core doesn't really do anything other than synchronization on these nodes. And then later we're going to be adding the modules to compose higher level things like having the edges where data can be in the relationship itself. Does that make sense? That an edge is technically just a special form of another node that sits between the two. How many people have I lost in my explanations of things? Don't be shy. OK. All right. So with the 4 minutes left, I'm going to jump back to the demo. I'll just use this guy and show off some of the things getting started. So I'm going to say var gun equals gun http gun.js.heroku app.com/gun. And now I have a gun instance. I'm going to do gun.put, which is hello node, if I can type. And gun.val should pull it back. Hang on. Let me create a key. So then I have one issue where I'm pulling from GitHub for this example, but then it has code that's not in the stable release, so there's a couple of bugs. If I do gun.put some object, and I put a key on it so I can reference it later by test example foo, I can now refresh the page and gun.get that same key to pull it in, .val. OK, so I'm pulling from the wrong source code, so I can't demo it there. But I don't have enough time to switch over to a source that doesn't have that bug currently in it. But any other questions in the last 2 minutes? Has it been a good introduction to how to get started with Gun? Did it look easy and simple enough? Yeah? It's all open source. Like I said, we're hiring. So if you want to contribute for free or for pay, please let me know. Yes?
So you said it wasn't ready for production.
Correct.
So this is mainly for personal projects at this point?
Right now, it's for experimenting. Tell me about the bugs and the problems. And then hopefully, in 9 months from now, we'll have a production-ready, stable release. So the ultimate goal is to have kind of an open-source Firebase, but rather than being limited to documents only, have the ability to have graph structures. So that way I get both the NoSQL and the SQL side. We're going to be adding SQL support as one of our next features. And then from there, you don't have to worry about any of the DevOps or the sysadmin stuff, because even if your server crashes, there's a copy of the data that's on not only the peers, but then hopefully in some backup like S3 or Google Cloud Storage or something like that. Yes?
Do you plan on moving into or integrating with other languages?
after we nail this niche. So that could be quite some time. But somebody was working on a Java version of it. And so we're really open if you know Go or Python and want to help port. The entire code base itself is actually surprisingly tiny. The core is less than 1,000 lines of code. It says $12.99 because that's including, I bake the browser plugins with it. But if we jump down to right here, that is where Gun Core ends. So there's only 982 lines of code. And that's because Gun Core literally only focuses on the wire protocol and the synchronization algorithm. And then most everything else is left up to modules and extensions to build on top of it. All right, thank you so much for the talk. Please talk to me afterwards. I'm more than happy to get people set up if it wasn't already easy enough. And if you, did you have a question? But everybody else can feel free to head off to the next talk. Thank you.